just a waste of my time. So we want to take the first derivative test to find local maxes and also local mins. So let C be the critical point. So that's going to be our root in when we factor out our derivative function. So if f prime of x, or if the derivative of f of x changes from positive to negative at C, then f has a local maximum. So if it goes from positive, so if my slope is positive, so if it goes from down up, so this means my slope is positive, and then my slope is negative, then I can assume that at this point up here is going to be a max, because it increases first and then goes back down. Now, if the derivative of f of x goes from negative, so it goes from a negative rate of change to a positive rate of change, I can assume that this will be a minimum because it decreases and then increases at that critical point. And if f prime of x does not change sign, so if it continues and it goes up, and then it continues going up, then there is a point of inflection, which means that it is not a max or a minimum, but there is a slight bend at that critical point. So the rules or algorithm, or whatever you want to call it, for finding critical points is find the critical points for what x values in the domain of f are the function where f prime of x is equal to 0 and f prime of x is undefined. Use the first derivative test to analyze whether f is increasing or decreasing on either side of each critical number. So you want to use a number line / scale. And we want to conclude if each critical point is going to be a local maximum, local minimum, or neither. Let's go to example 1. For each of the following functions, determine the critical points, then sketch the function labeling the critical points and the y-intercept. So let's get this out of the way. I might as well start with my y-intercept. So let's evaluate f at 0. So I get negative 2 cubed times 3 to the power of 2, which is negative 8, times 9, which is negative 72, which means that my y-intercept is at 0 and negative 72. Okay, so we got the y-intercept down. Now I need to take my first derivative test. So let's figure out what my derivative of p of x is and my derivative of q of x is. So this is a power of a function rule. So my derivative of p prime of x is going to be 3 times x minus 2 squared, and q prime of x is going to be 2 times x plus 3. So now I can take my derivative, so I get f prime of x is equal to 3 times x minus 2 squared times x plus 3 squared plus 2 times x plus 3 times x minus 2 squared. So I'm going to take my common factor, which is going to be an x minus 2 squared. It should be 3. That's my bad. And I get an x plus 3. Those are my common factors. So what I'm left with is 3 times x plus 3 plus 2 times x minus 2. Now I can expand and simplify my inside of that bracket. So I get x minus 2 squared times x plus 3 times 3x plus 9 plus 2x minus 4. And that leaves me with x minus 2 squared times x plus 3 times 5x plus 5. I can factor out a 5 from this, and I can just move it to the front of my equation. Which means that f of x, or f prime of x, is 0 when x is equal to -3, -1, and +2. So now I can draw my sign chart to determine where my graph is going to be increasing and decreasing. So let's have my sign chart. I got -infinity, -3, -1, 2, and infinity. So I have 5, which will always be positive across all of these numbers. I then have x plus 3, or we can go in order, x minus 2 squared. We got x plus 3, and we got x plus 1. And then I got my product at the end. So any number squared, guys, is always going to give me what type of number, positive or negative? Any number to the power of 2 is going to give me what? A positive or negative number? Positive. So this is going to be positive, 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 positive. So I'm going to pick a number between -infinity and -3, which is -4. So the first two are positive, and my last two are negative, which means that I get a product of positive. And I pick -2. I get positive, negative, gives me negative. I pick, let's say, 0. I get positive, positive, and then I get positive. And I pick 3, and I still keep getting positive. So, as we can see, because between -1 and 2, and then 2 to infinity, it keeps getting positive, there's going to be a inflection point at x is equal to 2. Okay, so that means my graph is going to bend. So now let's evaluate f at -3 in my regular function, because that's where my point or my change is going to happen. So I got f at -3 is 0. F of -1 is going to be -108. And f at 2 is going to be 0. So I got my point -3 and 0. I got my point -1 and 108, which is somewhere down here. I got my y-intercept of 0 and -72. And at an x value of 2. Oh, the reason why it bends, Mohammed, is because from -1 to +2 during that interval, my rate of change for the tangent is increasing, okay? And then once it passes 2 and continues to go to all the positive x values, the slope of my tangent is still increasing. So when there's no change in direction of the graph and it still continues to be the same sign, there is going to be a point of inflection, which is just a fancy way of saying there's going to be a bend in my graph. So I'm going to show you this right now. So from -infinity all the way to +3, I'm going to be increasing. And then after +3, I'm going to be decreasing all the way to my minimum at x is equal to -1. And then from 1 to 2, I'm going to be increasing. But then when I hit 2, I'm also going to be increasing again. So I'm just going to show it to you guys in terms. So my red line is going to be my slope of my tangent. So the slope of the tangent is increasing from -infinity to -3. From -3 to -1, my slope of the tangent is going to be increasing. after -1, so after it turns from -1 to +2, my slope of my tangent is going to be increasing, but after +2, it still increases. Okay? I'm not too sure if that helps you out, Mohammed. So is it clear? Does it make it clearer now? Yeah, so if it was decreasing, it would just be a decreasing inflection point. So let's say if we had something like this, and if it was still decreasing, there would be an inflection point over here. Yeah, because my slope of my tangent is decreasing, but after this x value, it's again decreasing. So there can be a point of inflection if your slope of the tangent is negative. It'll just be coming down instead of going up. So the next one we have is f of x is equal to x minus 2 to the power of 1/3. So I get my derivative is equal to 1 over 3, x minus 2 to the power of -2 over 3. So I have to set this equal to 0, and I get 1 over 3 times x minus 2 to the power of 2 over 3. And if I isolate for x and I cross multiply, I get 0 is equal to 1, which is never possible, which means there is no solution to this graph, which also means that f of x, or f prime of x, is undefined when x is equal to 2, because of our denominator. Cannot have denominator equal to 0 because we get an undefined number. Or we don't even get a number, it just becomes undefined. So now we can find my y-intercept, so f at 0 is equal to -2 to the power of 1/3, which is equal to -1.3. Gonna be around here. And at -2, my graph is going to be undefined. So which means there's probably going to be a hole or an asymptote there, depending on the graph. Which means that my graph is going to be, when x is equal to 2, Mohammed, is when my graph is undefined. When x is equal to 2 is when my graph is undefined. Because if I sub in f at 2, I'm just going to get 0. Oh, x equal to 2, sorry. That was my apologies. So my graph based off Desmos is going to look like this. So it's going to be undefined at 2. Because my slope of my tangents are always increasing throughout the graph. So if I have my sun chart, I know at -2 or at +2, I have undefined. But if I have x values greater than 2, my graph is increasing. If I have values less than 2, my graph is also increasing. Which means that as small as my tangent is going to be, it is always going to be increasing as we continue to go along the graph.
Night school staff, please initiate fire drill
Damn.
procedure.
Sorry guys, I gotta
Night
go.
school staff, please initiate fire drill